We're going to use the quadratic formula to solve this quadratic equation. We get 0 on one side first. That lets us know the coefficients a, b, and c. We write those down so that we have them carefully planted in our mind, and then we use this formula. Perhaps the easiest way to use the formula is to talk yourself through it. So we have x equals the opposite of what b is. B is 3. The opposite of that is negative 3. Plus or minus the square root of b times itself. That's 9. Minus 4 times whatever a times c is. A times c is negative 10. The entire thing is over 2 times a. So we have x equals negative 3 plus or minus the square root of, this is 40, 9 plus 40 is 49, all over 4. So we have x equals negative 3 plus or minus positive 7, all over 4. This gives us two solutions, and since we have all numbers, no square roots, we actually have to work them out. So x could equal negative 3 plus 7 over 4, or x could equal negative 3 minus 7 over 4. This is x equals negative, wrong. This is x equals 4 over 4, which is 1, or x equals negative 10 fourths, which equals negative 5 halves. So these are the two solutions to the original equation. They would check if you put these two values in for x here and here. You might consider doing that check. We're going to do the same thing here. We have 0 on one side, so we can read off the coefficients. We have an understood a equals 1, because that's 1p squared. We have an understood b equals negative 1, because that's minus 1p. And we have c equals positive 1. This time we don't write x equals. This time we write p equals the opposite of whatever b is. B is negative 1, so we have 1. Plus or minus the square root of b squared, 1 times 1 is positive 1, or negative 1 times negative 1 is positive 1. Minus 4 times whatever a times c is. A times c is 1, all over 2 times a. A is 1, so 2 times a is 2. So we have p equals 1 plus or minus, and this is the square root of 1 take away 4, which is negative 3, all over 2, and that is 1 plus or minus. This is the square root of 3 times I, all over 2. At this point, there is no real simplification that can go on, so I suppose we could stop right here. Also possible is to break them apart into p equals 1 plus the square root of 3i over 2 and 1 minus the square root of 3i over 2. Lastly, if we want our answers to be in a plus bi form, where these two are separated with a plus sign or a negative sign, we could distribute the 2 on the bottom here to each part of the numerator. This is not always super useful, and so I'm not real big on it. I would accept this, this, or this. They're all good solutions. There's nothing we can do to simplify them any further. In pleasing the software, if you're using the software, that's a different story. You gotta feed it what it wants. But in terms of getting a test question right, I don't really care which way you do it. Here again we have 0 on one side, so we can write down that a equals 1, and b equals 4, and c equals 6. And so we have in this case x's that we're solving for. X equals the opposite of whatever b is, plus or minus the square root of b squared minus 4 times whatever a times c is. A times c is 6, all over 2 times a. So we have x equals negative 4 plus or minus the square root of 16 take away 24 is negative 8, all over 2. This equals negative 4 plus or minus, And then we need the square root of negative 8 to be simplified. It is the square root of 8 times I, which is the square root of 2 times the square root of 2 times the square root of 2 times I, which is 2 times the square root of 2 times I. This 2, as we have seen in the previous example, can be distributed underneath each part, and that allows us to simplify this into negative 2 and simplify this into the square root of 2i with some canceling. And so we have that x equals negative 2 plus or minus the square root of 2i. Here we don't have 0 on one side, so we take away 40 from both sides to get 0 on one side. That lets us write down the coefficients. A is 12, B is 17, C is negative 40. And we're ready to go with the quadratic formula. We have, in this case, t. We're solving for the letter t equals the opposite of whatever b is, plus or minus the square root of b squared, which is 289, minus 4 times whatever a times c is, and that looks like it's going to be negative 480, all over 2 times a, which is 24. And so now we have t equals negative 17, forgot the minus in the plus or minus sign, plus or minus the square root of 289, and then we have 4 times 480, which is 1920, divided by 24, and that equals negative 17 plus or minus, and we have to add 289 to the 1920, and we get 2209 divided by 24. The reasonable thing to do at this point would be to find the square root of 2209 on a calculator. I decided it was a perfect square, and I guessed that 47 would be the right size because 7 times 7 ends in 9. But it was sort of lucky guess, right? So we have these solutions. Since there are no square roots, we have to work them out separately. So we have negative 17 plus 47 over 24, which is positive 30 over 24. Divide top and bottom by 6. And we get 5/4. So t equals 5/4 is one solution. And then we have t equals negative 17 minus 47 over 24. And what is that? Let's see, negative 50, 64, negative 64 over 24, which is negative. And then we can divide top and bottom by 8. So we get negative 8 over 3. So we have negative 8/3 and positive 5/4 for our solutions to the original equation. And they would check.